In this video, we'll be reducing some rational expressions. So the first step in reducing rational expressions is to factor the numerator and the denominator of the rational expression. And then the second step will be to cancel out anything that's common. So first thing we need to do is to factor. So I'm going to draw the fraction bar here. I'm going to factor the first trinomial on top of the fraction here. So I'll use two parentheses. That's our standard procedure for factoring a trinomial. The x squared there can be factored as x and x. Because we have a negative sign in the back end here, it'll be a plus and a minus. And then from there we need factors of 15 that subtract to give you 2. So factors of 15 that subtract to give you positive 2. Well, the factors of 15 that subtract to give you 2 would be 5 and 3. So we're going to pick 5 for the positive and 3 for the negative. Now, okay, so now that that's factored, let's factor the second trinomial here. This x squared will be split up as x and x, right? The fact that this is positive, it means two negative signs. So minus, minus. And then we need factors of 12 that will add to give you negative 7. Well, that'll be minus 4 and minus 3, because those two numbers multiply to give you positive 12, but yet add to give you negative 7. All right, this is very good because we see that we have a match, x minus 3, x minus 3. That's your step 2, canceling any common terms. And so the final answer is simply x plus 5 over x minus 4. Okay, let's take a look at the next example here, example B. Example B is sort of a special case. If you look at it, we have a situation where the 2 in the numerator here, this 2, is actually positive, while down here it's negative. Then you can see that we have a negative 5x in the numerator, but a positive 5x in the denominator. So this is a very special case because basically we have the same terms in both the numerator and the denominator, but they have opposite signs. So the standard trick that most people are taught is to factor out a negative 1 from the top to change the signs. Remember, factoring is just dividing, so we can actually divide each term by negative 1 in the top of the fraction to change the signs of that numerator. So I'll have negative 1 divided into positive 2, which will give me negative 2. And negative 1 divided into negative 5x will give you positive 5x. Then the denominator will be 5x minus 2. Now from here, there's a couple of things I want to point out, and that is that you could certainly show that if you distribute in this negative 1 back into the parentheses, you would end up with the original numerator. Now we want that to be the case. That's just to ensure that we've done the factoring of the negative 1 properly. And the next thing I wanted to show is if you rewrite the terms here, in the denominator, so that the negative 2 is first and the plus 5x comes second in the denominator, you can then clearly see that the top of the fraction and the bottom of the fraction are identical, except for that negative 1 that's sitting out in front. So when you divide these two binomials, you end up with negative 1 as your result. Okay, let's do our last example, example C. And for example C, we're going to perform the same procedure, factor first, then cancel out anything that's common. Okay, so let's go ahead and factor and then begin to cancel out like terms. For the top binomial, it looks like I have a greatest common factor of x squared. So if I take x squared from 3x to the third, I'll have a 3 with an x left over. Plus, if I take x squared out of x squared, I'll just have 1. All right, from there, the top is fully factored. We won't be able to take that binomial 3x plus 1 any further. That's prime. Let's move down to the denominator now. It looks like we also have an x squared in common down there. So I'll factor out an x squared. And let's see what that gives us. Well, we'll have 3x squared left over after we take x squared from x to the fourth. I'll have minus 11 just x, because we had x to the third before. Taking out x squared, we'll have just x remaining. Minus 4 after we remove the x squared. Okay, from here we can already begin to simplify a little bit because these x squareds will cancel out, leaving us with 3x plus 1 divided by, now we want to see if this trinomial can be factored, so let's go ahead and split that into two parentheses and see if we can factor it. So it'll be 3 and 1 for the 3 split up in the first two positions, and then put x and x there, right? Now from there, looking at the sign on the back end, it means I'll have a sign of each. and we need to factor this by finding factors of 4 that will fill in these little binomials properly. So what are the factors of 4? Well, we have 1 and 4, and then we have 2 and 2. Now normally I would try the closer pair first, the 2 and the 2, but since I know the purpose of this problem is to reduce the fraction by canceling common terms, I look over here and I see this 3x here, and I notice on top we have a 3x plus 1. That might make me want to try 3x plus 1 here so that I would have a common term, right? That makes me want to force a plus 1 to go here so that I can cancel these two binomials when I'm finished. But if that's plus 1, then this would have to be minus 4, because then I'd be using this pair of factors, correct? Making the 1 positive and the 4 negative, because this minus sign here is telling me that I must use a sign of each. So let's check the middle terms and see if that is correct. Well, I'd have 1 times 1, which of course gives you just 1x positive, right? And then I would have 3x times negative 4, which will give you negative 12x. And when I combine these two, I do indeed get negative 11x, which is the middle term we were looking to find. So since that factoring is correct, I can just cancel these two terms, and I'm left with simply 1 on top and an x minus 4 on the bottom. And that's it.